0. Hi, and welcome to Biotopia and our celebration of this day and night. I'm very happy that we have 4 excellent space researchers. Can I say so? They know stuff. I don't know stuff that much. So that's why we have brought all of you here. And we're going to do this in a very easy way. We're going to speak. We're going to ask you questions. You're going to tell us all about space and how it works and what we know and what we don't know. And we will listen and learn and ask you even more stupid questions that we haven't understood what you said. So, you can also ask questions if you use the Menti. You can use your phone and just go into menti.com and write down the code, which I may be supposed to say, but 111777773. So just give us all your questions. We already did this with kids today, and they already have given us questions. So now it's your turn to give up the questions. But maybe, my name is Anna, and I work at Biotopia. I'm a biologist, that's why I know space expert. But you are, so tell me your name.
My name is Erik Stempels. I'm an astronomer here working at Uppsala University, and I'm involved in, among others, projects to build instruments on big telescopes that are going to look out into space and find new things.
Ooh.
All right, my name's Adam. I'm an Australian astronomer working at Uppsala University. I like to say that I study space rainbows, and I look at stars that are smaller in size, redder in color, and cooler in temperature than the sun, and try to understand what's going on with their planets.
Cool.
Hi, I'm Vicky Cripps. I'm an engineer working at the Swedish Institute of Space Physics. We work very closely with the astronomers at Uppsala University, and we are building scientific instruments that travel out on the satellites out into our solar system.
Okay, hi, I'm Emily. I'm a PhD student at Uppsala University, and my study is about dying stars and modeling the stellar winds of dying stars.
Oh, sounds a bit sad.
Well, I mean, that's circle of life, I guess.
Circle of life,
Yeah.
Oh yes. So, when I was preparing for this, I did some studying, which means I was watching Interstellar, the movie. We're going to speak about space traveling, because that's a bit of the theme from this Astronomy Day and Night. And where are we standing in the field of space traveling? Are we going to be able... We have been space traveling, but to the moon, but further. How is it now? Anybody feeling like, where are we now?
Well, I can start because I've been involved in a very big project recently, JUICE, Jupiter Icy Moon Explorer, where we are sending a satellite all the way to Jupiter. We have gone further with other satellites, but at the moment we are contained within our solar system when we're talking about satellites traveling there. We have managed to land on comets, land on the moon, as you say, and people, as many people know, have landed on the moon. The next step is what will happen next if people are going to travel further, if people are in fact going to go to Mars. And then beyond that, do we send people or do we send machines? That's a big question.
What do you think?
I think that humans are not the best entities to travel. I mean, we aren't built for living here, and we are interested in space and everything around there, and we might want to explore, etc. But we're really not built for this, and this is one of the reasons why we've only been to the moon, because the moon is very close in terms of our solar system. And in our lifetime, I think we might see efforts to bring people to Mars, but in my lifetime, I think that's more or less where it will stop, unfortunately. So Interstellar is something which is for the movies.
No.
It's nice.
It's nice.
Yeah.
But that's also in the future. But do we need to go to Mars? Since we are kind of lousy in the space, the way we are built. And why would we go to Mars? That's a question.
Well, if you see that humans been sent into space, humans are on the space station, not just only for having humans there, otherwise we wouldn't be there.
No, it's
and that's because humans are good at doing things. A machine can only do what the machine is built for, even it can have a lot of different things to do. But humans can interact, can learn, can solve problems. And one good example is the Space Telescope. The Hubble Space Telescope at one point had to be repaired by replacing a big camera in the Space Telescope. And while doing this, they had a problem with, I think it was opening some kind of doors. And they needed to unscrew a particular screw. Then they went back and then they found a way to actually unscrew the screw and then replace the instrument anyway. If there had not been humans on that mission, it would have been impossible.
And we've been all a waste of time. And
yes, exactly.
Yeah.
Whereas, and it's the same for bringing people to the moon. They can do things that machines cannot do. So that's probably a good reason to think of bringing people to Mars.
So there is a point of bringing people to Mars, even if we...
Especially in the beginning. Eventually, probably machines will take over a lot of the tasks that we would be able to do.
Oh, we have some questions. Are we ready to start with some of your questions also? How do we keep space clean? For example, to clean up debris in orbit and minimize space junk. We do send out space junk, right? Or
yeah, so many satellites that have been up in space have then collided with other things, or even have been shot at by certain countries, and then break up into millions of small pieces. So space is full of junk.
So what happened to that junk?
It's orbiting around the Earth. Some of it falls back into our atmosphere and burns up. But there is a lot there, so there are people who track it carefully, but at the moment it is unregulated, so there is no requirement that people clean up after themselves in space. When we now build instruments and send satellites up for the European Space Agency, ESA, we are required to do something with our satellite at the end of its life. So in the example I gave before, JUICE, that will crash onto Ganymede, one of the moons of Jupiter, and remain there. Other missions, they bring them back to Earth and they burn up in the atmosphere. But there is loads of stuff out there, so it's going to be a big business in the future for someone with lots of money to start a business to start collecting all this debris, because it's something we have to consider when we're launching all the communication satellites and scientific missions, to work out where all this junk is, and also how we can protect our satellite as much as is possible, because things break, because they get hit either by debris or natural meteorites up in space.
Is it like when we used to throw everything out in the ocean and it was like, it's just in the water, nobody cares?
There is no regulation at the moment on what every country sending satellites up should do. So some countries, some space organizations are trying, but not all of them. So,
That's interesting.
So I guess connects a bit to this question, but how are private companies changing the field as well? So there's increasingly a lot more satellites that are going into space, and they can do amazing things like give internet to rural areas that maybe, are disconnected from the internet that we have in cities. But in the same way, if there's more and more of these collisions, it makes more and more of a mess because these satellites are moving as fast as bullets. And then if one satellite hits another satellite, suddenly instead of just 2 things moving as fast as bullets, you have 10,000 things moving as fast as bullets. And so in the horrible case, what could happen is that we have so much space junk that we can't put any more satellites up there, which means we can't use any GPS anymore. And our whole modern society relies on that. So the decisions we make in space affect everyone on the planet. So, because we all use satellites in our day-to-day lives with, our phones and GPS and stuff. And then as more satellites go up as well, like we can think of light pollution, and that's typically something that there's an issue in cities. Like if, you go out in Stockholm, for instance, and look up in the night sky, you might not see many stars because it's really bright of all the city lights. But the more and more satellites we put up in space, suddenly you can see all these satellites moving across the sky in country areas as well. And so these decisions affect everyone on the planet. So we've got to make sure that we, as a globe, as a species, make the right decisions to affect everyone and make the right choice.
Yes, definitely. Wow. Let's see if we have any. Yeah, how many? So is it going back to the space traveling question about and private company? Do people go out to space as a tourists nowadays? Is it really happening, or is it just some really rich people?
Rich tourists.
Rich tourists.
It happens.
It happens.
It happens.
Yeah.
Unfortunately, I would say, because it takes a lot of effort, takes a lot of energy and money, which could be spent on maybe much better things. But it's people want to do very strange things and take all kinds of risks to have some kind of unique experience. And I think that's not where the money should be put.
Definitely not. But so how safe is it to go out nowadays?
Well, it depends where we're going to. If we're talking about Mars, then things are untested. So it's a whole nother ball game than going to the moon, where a fair few people now have been. But to build a manned mission compared to sending scientific instruments up is a completely different requirement. So, excuse me, I work as a quality engineer, so it's my job to make sure we're doing the right kind of testing. If we were testing something that we're sending up with people, so stuff for the International Space Station, for example, that has been tested to a whole nother scale. So it's more money, more time to spend on ground as well. Back to the private companies question, then we have, of course, Elon Musk and SpaceX coming into the game as well. They do things quite differently. So they test, let it explode, see what happens, whereas the sort of NASA side of it, they do things much more cautiously, step by step, building lots of test models on ground and so on. So it's not safe for people, I would say. when we're going further afield, I wouldn't want to be an astronaut. Let's put it that way. So.
Not?
No.
Are you sure?
Oh yes.
Oh. It's a lot of things you need to do when you're an astronaut. There's a question about the astronauts going to Mars. We almost answered that one, or why haven't we gone to Mars? This is so strange. I'm still
I think that ties in with your previous answer right now. We probably don't have. It's not tested enough. Maybe we don't know. Don't have all the right knowledge right now, probably, or equipment or things like that to actually do it. underway.
Is
Maybe?
it the problem is it the way over there or staying there? What's the biggest problem?
Everything. It's if we're talking going to the moon's a few days away, and so if something terrible happened, hypothetically, it's only a few days from rescue. But it takes, in the best case, I think 7 months to get to Mars. And assuming all goes well, and then something goes wrong there, then a rescue mission takes 7 months. And some of you might have seen the movie The Martian. That's goes into a lot of the detail about the various complexities of going to Mars and why it's so much more complicated than just going to the moon or being in the International Space Station. We just haven't done it before, and it's there's getting to Mars, living with people in a spaceship for 7 months. I don't know, we're in Sweden, so we've all experienced Swedish winters. You get stuck inside with your siblings or your partner or your housemate for a couple of days on end, and that's maybe a bit much, let alone 7 months straight. And then there's on Mars as well, which is a hostile environment compared to Earth.
Yeah.
It'll take a lot of smart people to solve these problems.
Yeah, so about the Martian, there's a thing I've been thinking about. Can you grow potatoes on Mars? Because we know a bit about Mars, right? We have had rovers going there and taking a lot of measurements and so on.
So there have been experiments on Mars trying to test the soil, mainly to find out if life, as we know it, would be possible on Mars. And what they find is that there are some chemicals in the surface of Mars that make the surface very salty and not very nice, so we wouldn't be able to really grow potatoes in the way we grow them here. Maybe there are crops on Earth that we would be able to grow on Martian soil, but we will probably have to add a lot of things to make things work. It's not as simple as it is just to put potatoes in the ground and it works. The environment on Mars is not very nice for the kind of life as we know it, which doesn't mean that it may still survive somewhere deeper on the ground or so. But it's pretty challenging.
So is there any other place we would prefer grow potatoes? What do we know about the soil and other planets, or we don't know so much?
Well, we know about the Earth, and the Earth is very unique.
Still, it's hard growing potatoes.
So when you think about traveling out from the Earth, you have to compare how things are on the Earth. The Earth is very unique in terms of its atmosphere and its surface as well. And this has to do with we have a lot of oxygen in the atmosphere. The oxygen in the atmosphere oxidizes a lot of the surface of the Earth, which creates lots of minerals which are not available typically in a normal space environment. So the moon has a very dull mineralogy compared to the Earth. And then we are life that live on this special place on Earth, and we try to put ourselves into these dull places. That is going to be very difficult because we are in such a special place.
See if I... are there any good scientific motivation for the recent rush to the moon by many nations?
Good question.
Oh.
I think it's very interesting from my perspective seeing how India has developed.
Yes.
Yes, now.
Yeah.
Yes, I think it's very interesting to see how India has developed as a nation. They have now quite highly developed space industry and space research. They are doing really good work, and the moon was a chance for them to demonstrate that. They are building all sorts of missions and have very highly trained engineers and scientists now. So who knows now, if through that development, what they might come up with as well. Some of the other countries, perhaps that's more politically based, why they've chosen to go right now. But a big part of why the moon is interesting again is then the hop to be able to travel further. So traveling out to Mars or further afield, we're going to have to either take everything with us or generate it when we're there. So there's a lot of work going into the moon as being a base where we can dump stuff or generate oxygen or things up there, because every time we launch something from the Earth, it takes an incredible amount of energy to get out of our atmosphere and gravitational field. So if we have a substation on the way where we can stop off, refuel, gather what we need, and then go further. So there is a big race to be able to build something on the moon now.
But it's, how is it to take off from the moon afterwards? Is it less energy?
Yeah, here one of the physicists can help me out, but yes.
Yeah, so the moon's, because it's much smaller than the Earth, it doesn't take as much energy to launch a rocket from it. So the idea of having a sort of a halfway station on the moon or in the orbit around the moon, you don't always then need to come back down to the surface of the Earth, because you see these amazing like NASA rocket launches, and it takes a phenomenal amount of energy to launch a rocket into space, whereas if you're already in space, maybe you don't come back down, and maybe you make your fuel to go to Mars on the moon rather than making it on Earth and getting into space there. And you also can do stuff like I was saying before. We've got to do a lot of testing and solve some problems before going to Mars, so maybe we could solve some of those problems on the moon. Maybe we could make the moon and Mars are different places, but we could test some things there so that we know they're going to work when we get to Mars. Try to make it so there's minimize the risk as much as possible when we finally commit to taking people to Mars.
And we use the planet's gravitation to get even further, right? There's so it's also a good way. We have a question that I really want to ask you now, because we were talking about the death of stars. So how do they become alive, or how do they start stars?
Yes, good question. So, like I said, it's like this life cycle. So actually, dying stars is what sort of brings the material that will later become new stars. So we have like a lot of gas and dust that's just floating around in space. And the more dust and gas that is sort of dumped into this region eventually there will be a huge like dust and gas cloud, and that will like collapse under its own gravity. It's a long process. So I don't know how many million years it takes for it to actually ignite then the nuclear burning in the core. But then I guess it also has to be large enough to ignite in the core. And I guess I'm not sure the limits. Is it like around a half solar mass, I think?
To be a star?
Yeah.
I think it's about 8% the mass of the sun.
It's 8%. Oh, yeah.
Yeah. So
sorry, I was thinking about. Sorry.
That's all right. There's too many numbers in astronomy.
Yes. Do you know all the numbers by heart?
Yes, I've got some of them written in here. 6.
Oh, I know that.
Yes. But yeah, there's lots of numbers. But if you've heard of like red dwarf stars or our nearest neighbor, Proxima Centauri, or maybe you've heard of a fancy planet system called TRAPPIST-1, which has a bunch of planets that go around it, some of which may or may not be like Earth. TRAPPIST-1 is about as small as you can be and still be a star. But I guess the stars that you study are much bigger, and they die in different ways.
Exactly. They start at about a half a solar mass. That's the one. Yeah.
Is a bigger star better stars? They die more interesting.
Does that make them better?
I don't know. How do you rate stars?
I mean, the most common stars are the smaller stars, right? So the bigger stars are more rare, I guess. Yeah, and they burn up their fuel so much faster as well.
So it goes faster, even if they have more stuff to burn.
More mass. Yeah, exactly, because the gravitational pull is much stronger, I guess. Yeah, and they burn the fuel a lot more efficient than in lower mass stars. Yeah.
This is really hard to do, reading the questions backwards or with my head. Okay, with the present day technology, how long would it take to travel to the nearest star?
I think I read pretty recently that, I mean, we have some satellites that have, they're on the way to leave like our solar system, right? The like Voyager, Pioneer. I think I read somewhere that if they are not aimed at a specific star because they had missions to look at the planets in our solar system, but if they were going towards our closest star, which is 4 light years away, right? It would take something like 80,000 years to get there in their current like speed and yeah.
So that's why it's so important with wormholes.
I guess so, yeah.
Mm.
I watched too much movies.
But those satellites, they were never built to go to the next
No, exactly.
star.
Yeah.
There are some experimental spacecraft that could use a different kind of technique that would continue to accelerate during their travel and then reach very high speeds. But those satellites would also be very tiny, like
Is it
almost like
that tiny?
microchips. Yes.
Ah.
And then the idea would to send off a big swarm of these, all in the same direction, and hope that some of them will survive the journey. And because they are small and can keep accelerating, then maybe the travel time can go down to something like 100 years. But then they would also pass the star.
Quite a lot of
it's
shorter time.
Yes, it's shorter time. Also, they go much faster. So when they come to the star, they have to, they will not stop there. They have a huge speed. So they will be whizzing by, and during the whiz by, they have to make a picture of whatever they're seeing and move at the correct rate. It's going to be very difficult to do it. And that's why they want to send a lot of them and maybe get some information of the closest stellar systems. But this technology has not been deployed yet. But
When
this
will
is
this
something that
happen?
maybe within 50 years there could be an experiment like that. But still, then you will not get the answer for another 100 years.
Because you need
It will
to
take time.
take time to...
Yeah, unfortunately, scientists haven't yet discovered, light speed or warp drives or slip space drives.
Why haven't you done that?
We're lazy. That's the main reason.
Well, I understand that. I haven't solved it either, so I shouldn't say anything. But is it possible to do warp speed? I haven't really understand what it is.
These are science fiction. To kind of make science fiction stories work, you often need to invent a way to quickly get between places, and so there's a bunch of different ways that have been invented. I mean, you mentioned wormholes before. Like, wormholes are possible, as far as I understand, with physics, but to hold them, to keep them open would take a lot of energy. But unfortunately, the universe and the galaxy is just really big, and times are really, really, really long, whereas we as humans kind of get 80 years and that's it. So the universe just isn't really nice to us on our special little rock with our special little gases in the air.
But these really, really tiny new space ship thingies, could they use wormholes easier because they are so... Because I guess there's a problem when you go through them with the mass and that they collapse. That's something that doesn't weigh anything.
Sorry, what did go through?
If you can the small spaceships go through wormholes?
Well, small spaceships are still very large.
No, but not the new ones you were talking about, the really small ones.
Yes, but even small spaceships are very large in terms of the quantum sizes that you are looking at. Because yes, you can have solutions to space-time that involves wormholes, but in order to get through it, you have to be of a quantum size.
Quantum size,
and
that's
we are
quite
not
hard.
quantum size. That's
No.
very hard. So this is also something that happens often, that you see that the more normal it is in movies, the more often it's used, the less likely it is that it's actually going to work. And the only reason it's there because it really simplifies the story.
It would simplify it. Oh, we have a question that I don't really understand. Ion drive propulsions. propulsion.
We
How do
have
you
a
say that?
narrator that can narrate the questions.
How does that work? Does it work? So,
Ion drive propulsion.
iron drive propulsion.
How does that work? And does it work?
Thank you, kindly narrator.
Thank you, Danny.
Yeah.
So, nobody
No.
knows?
Do you want to take it? Or?
Yeah?
No, I think this is still something that is for the future. There are different ways of propulsing spacecraft, and it's always based on sending out something from the spacecraft, something small at high speed, to give the big spacecraft an additional push. And using ions is more efficient because ions are charged particles. And charged particles, they react to magnetic fields and electric fields. So you give them additional speeds rather than from explosive drives. So you can use that. But then it's also a kind of engine that will only be effective on small spacecraft. So you have to have small spacecraft with small mass to have ion drives to really make the difference. So we will not see ion drives in the big things that are going to, say, travel people through our solar system, but rather small experiments that have to go far away.
Oh, we have a question about how many people has gone out to space. Do you know that number by?
No.
No?
I think it's a few hundred.
600. That's quite. Yeah. But how many people have been to the moon?
10?
10?
10
We don't
landed, I think. Yeah.
No.
Yeah. But there's a thing in this question is, what does it mean to go out into space?
Yes. Are we out in space now?
Or you could say so.
Well, as we keep going up, the atmosphere just keeps getting thinner and thinner and thinner, and I think the definition of space is such that it's just set at like 100 kilometers above the surface. And so this is the kind of thing we as humans like to have nice little boxes. And it's like, if you're on this side, not in space. On this side, you're in space. Cool. And so, you know, in reality, it's a transition. Like if you're on the top of Mount Everest, it's hard to breathe, and you keep going up and up and up, and you get to 100 kilometers, and now you're in space. But different, you know, the International Space Station, or all the missions that were done in the 60s and 70s in preparation for launching to the moon, like they were increasingly ambitious and would go higher and higher or faster and faster. And so space is a lot of different things, but one definition is 100 kilometers.
Wow, there's a lot of questions. Oh, is it someone who's... what are the chances that there are life in space? Maybe not life as we know it, maybe, but bacteria. Bacteria is life as we know it. So, anybody feel like answering that little question?
Well, I can go back to my favorite topic of the JUICE satellite. So we are going out to visit the icy moons of Jupiter because there is water. Where there is water, there may well be life. Particularly Ganymede has a very high percentage of water compared to Earth. So yes, if there is the right conditions, then yes, there could well be. Further afield, then investigating the exoplanets, which is more what these guys get up to. It's possible, yeah.
When you say exoplanet, how much do we know about the exoplanets that we have seen?
Not as much as we'd like, because planets are really small compared to their stars. And so one of the things I do with my time is I try to understand the atmospheres around distant planets. So one of the ways we can study the atmosphere of a planet is if you imagine that my head is a star, sometimes a planet passes in front of the star from the audience's perspective, say. And if that planet has an atmosphere, some of the light from the star will get blocked by the planet. It'll just hit the back of the planet. Some of the light will just go around the planet, and some of the light will go through the atmosphere of the planet. And the gases in the atmosphere, whether it's oxygen or carbon dioxide or anything like that, will put a fingerprint on that rainbow.
Oh, that's the rainbow.
That's the rainbow.
Oh.
And so what we try to do is get our biggest telescopes to look when these planets eclipse or transit their star and try to look for that tiny little fingerprint. And so if we know that from looking at the planets in our solar system, that we can look at Jupiter and Saturn and say, hey, these big planets, they have, methane in them. And so we might expect to find methane on a planet. But one of the things we know about life is that life makes certain gases and changes its environment in certain ways. So one of the ways that we would want to look for life around distant stars, distant planets, because it takes so long to get there, is to see if there's like a fingerprint that could only be produced by life in the atmosphere of the planets. And so, certain gases in our own atmosphere are only there because life makes it. So if an alien was looking at Earth, they could maybe see that we were here before really seeing us.
Because of the gases.
Because of the gases.
It just makes me think about the gases not that kind of gases that is produced. But I was thinking, because there was on the news the other day about this molecular compound that they found. Can you tell us more?
So there's these things called biomarkers, and they're the kinds of gases that life makes. And so we know there are scientists who do their work in laboratories on Earth, and they'll know that, hey, this certain kind of gas, whether it's made by life or not, has a fingerprint, and it always blocks this kind of red light and this kind of blue light and this kind of green light. And so if we look at these planets in that color of light, we can see if there's a little bit of light getting blocked from the fingerprint. And so a biomarker is, we've come up with a big list of things by speaking to our friendly neighborhood biologists to try to see what what gases would make the biggest fingerprints on the atmosphere. And so recently, some scientists discovered or claimed a detection of a biomarker. And as always, in science, it's never just one thing. So now that this discovery has been made, other people will go back and look again and double check. Because in science, we're always talking to our peers and trying to make sure everything's right and check each other's work. It's very collaborative. So hopefully it'll be amazing if it turns out to be a biomarker, or it turns out to be really there, but we probably won't know for a little bit.
I guess it's a part of science growing. But I've been thinking, since what new do we learn about space nowadays? Is it because we have better equipment, or do you understand the question? Will we learn much more? Because it feels like we're learning more and more and more. Will there be a stop what we're learning? And what do you think?
I think we all come at this from different perspectives. So Amelia can talk about running simulations and how that tells us about our knowledge.
I mean, it's a continuous improvement. I mean, it's a process, right? To try to improve the simulations as much as possible and try to get as close to the observations as possible. But then also the observations will continue to improve. So then the models need. I mean, it's like a yeah.
Iterative.
Yeah, it's an iterative process, right? So we can only compare our models to the observations that we have today. But when the observations then improve, then we have something else to compare the model to. So it's like
keeps getting better.
It just yeah, exactly, yeah. So yeah.
And what makes our observation better? Is it more technology?
Probably, yeah. Like new telescopes, yeah, new satellites and things like that.
So there's continually improvements in how things are manufactured, so you can get even flatter mirrors and new developments in satellite technology. This is where it's interesting getting in some of these private players who come at it from a different angle, throw much more money at it, develop things much faster. But yeah, there's continually new ideas coming. How do we make it better from the last? How do we make it smaller the whole time when we're talking electronics? There will be a limit, but smaller means less mass, which means you can take it further in space with the same fuel, developments in fuel, and so, yeah, it's continual.
And the more data you get, the more you can...
The more you learn.
The more you learn, the more you can do theory about it, I guess. Let's see if we have any more questions. Which known planet is the best option for humans to live at? Oh, I know this one. It's here. This is a really good place. But if we're not supposed to be here, what? Anybody feel like? Where are we supposed to move?
Well, we don't have that many options. So if we look at the options in the solar system, then we only have the Moon, Mars, and Venus in our closest neighborhood. And which one of those is most like Earth? Because the answer is going to be anything that is most like Earth, because we are built for this place.
Venus is not nice, right?
No, it's not very nice. It's hot, it's acidic, it's high pressure, it can be very dark. The Moon is very dry, it's very little atmosphere, very little gravity. So Mars is, in that sense, the best option for those planets. And these are the only planets which essentially within our reach with today's technology and probably with future technology. Of course, it doesn't mean that there could be planets around other systems, other stars that could have properties which are like the Earth. But even then, in order to move there, we would like to have a planet that, in order for it to be anyway similar to Earth, would have to go through a long period of having an atmosphere that contains oxygen,
or evolution.
Or evolution, yes. So, and the reason we can be here is because there have been these 4 million years of effects of life that have changed our atmosphere and our climate and our environment, which makes it to what it is now. So the chances of finding anything that is similar enough for us to live on, they are so incredibly small. This is really tailored to what we are. So the question about traveling into space is probably not a question we should ask us out of a human perspective, but maybe out of a more post-human perspective. What would we do in order to travel to get there, and how would we design new life forms that may be adaptable to better climates, better scenarios? Or would we create something which is a mix of life and or machine in the future? Or do we make something which is more artificially intelligent to do that? So this is not something we can treat within the human perspective. This is something we need to treat in a much bigger perspective, which makes it, of course, incredibly difficult and not something we're going to do in the coming 10, 20 years.
Maybe we can take care of this planet so we can stay here.
Yes, that's a very good argument.
But if we were supposed to move away, would it better to move away to one of those not good planets, or to stay in a spaceship all the time? Do you understand? Yes?
They all have their benefits and drawbacks. So I'm getting a very circular motion from the audience.
Yeah.
There's lots of different kinds of spaceships you could make. So, you know, the International Space Station is relatively simple as far as space stations are concerned. It's like, you know, a bunch of corridors that have air inside. But you could have more complex space stations that maybe spin, and so like a big wheel, and so that you could be standing. You could feel like you have gravity, and so you could walk around. But then, you know, if something goes wrong on your space station, it gets a hole in it, then all the air goes out. Whereas maybe we're better off going to the moon and going to lava tubes onto the moon, and sealing those off, because then we've found a cave that we can seal off, and it's on the ground and it's protected because we got lots of rock over us. But I think I like your option best, which is don't destroy this planet, because anywhere we go is going to be more dangerous than staying on the Earth.
Takes us to this question. Is launching rockets from Earth damaging to the climate? It must be a bit.
Anyone want to answer the chemistry of that one?
any carbon dioxide we put in the atmosphere at this point is always going to stay there.
Yeah.
So unfortunately, anything we do, even if it's driving back home and you have a carbon fuel-based car, that carbon dioxide is going to stay in the atmosphere, which is going to contribute to all kinds of problems that we're going to have. That's the same for launching rockets. So from that perspective, anything we do does have an effect. I think the question is maybe more posed whether is launching satellites particularly damaging for the atmosphere? Does it contain something which is more dangerous than anything else? In that perspective, I would say, no, probably not. There are some tiny risks that are connected to some of the kind of fuels that are being used, which there are some fuels that are used in space because they are very fast in burning and they carry a lot of energy in the fuel, but unfortunately they're also extremely toxic. In all cases when rockets are used, these fuels are completely burnt, so there's nothing left there. But there is always some risk that something may go wrong and some of this might get into the environment, which will be highly problematic. But these kind of questions are always looked at when building rockets. These are the same kind of fuels that occur in military jets, etc. And would we choose not to have any military jets because of the environmental problems surrounded it? I don't know how to answer that question. But whenever we make new projects, these are things that is being looked at. And the risks are weighed against the benefits of doing that. So it is a difficult question. In general, anything we do at the moment is very bad for the climate.
I was just going to say, we can always think about the materials we use as well, because I remember a few years ago, I think at this point, some scientists were researching, maybe using wood as an interesting material to maybe make satellites out of. Because if we were thinking of disposing our satellites when they come back up and burn up in the atmosphere, well, maybe if your satellite is made of like a special kind of wood, and that sounds really strange because trees grow on the ground, but they're in space. But like all kinds of materials have good properties and bad properties. And so, but if something was more like natural, like wood, maybe it wouldn't be so bad if it burns up in the atmosphere. And it could have properties that are really good if it was in space. But this is why we think about all aspects of the life cycle from like when we're designing a mission, what are the risks when it launches, when things go well or when things go badly, and how can we do things better in the future?
And I always try to think of the bigger picture. Am I still on? So I've been at Science Fest this morning over at Fyrishof, and space is always one of the subjects that really captures the interest of children, the next generation of scientists. And they may be the ones who come up with the great idea of what we can do to help solve climate change. So I do think, within reason, I don't think we should be throwing all money at space, but it is really exciting, and we are developing future scientists and engineers because of what we're doing now.
And we get new knowledge all the time, don't we?
Yes, oh yeah.
Which is the most, your favorite new knowledge that have come, say, the last 10 years?
About space?
Yes, about space.
I mean, I guess I'm biased because I study planets, but 10 years is a very long, like 10 years ago in, 2013, we probably had maybe hundreds of planets that we know about. Now we know of more than 5,000. So like, my field has grown dramatically in a very short time.
More work.
Yeah, there's more work. So if anyone listening, I've got too much data. If you want to come help me look at it, that'd be amazing. But yeah, at least from my perspective, like studying exoplanets is a very young field, and there's now more connections, like speaking to biologists and like astrobiology as a field, and like speaking to chemists and geologists and stuff. It's astronomy and exoplanets in particular is very interdisciplinary because there's a lot of fields that need to talk to each other to understand things. I guess anyone else?
Favorite things?
Wow. What's most important?
It's a big question. I don't know if I don't have anything that like pops up right now. Probably need to think about that one. Yeah.
Is the use of AI gonna change the way we are looking at the data? Or
It is changing the way we're looking at
Yes.
the data. Because probably also connected to the previous question, the large amount of data that we're getting from all kinds of experiments, it's much easier for us now to do, to retrieve data in amounts that we could only have dreamt of 10 years ago. Some experiments, they don't even save the data. They just stream the data on the internet, and either you read it and you do something with it, or you just don't look at it. So much data they have. And in order to interpret these kind of data, we need to have good systems to find the signals in there. And the human eye is very good at catching patterns or identifying new things, and computer programs typically are not, except if you go to AI, because AI can be trained to look at things more like we use our human eyes for. And this is something which is going on. We'll probably see more. And this is the kind of revolution we essentially see in the field of astronomy, is that we're moving into an age which is called big data. There's so much data in so many fields that we have to somehow treat that this is going to, when we're start to be able to do that, this is going to revolutionize our view of astronomy and everything around us, because we're going to see so many more patterns. And if we see patterns, then we can start making a database, and we can follow the patterns, and then we can interpret the patterns that then leads to new theories, new descriptions of how things. I often compare it to collecting butterflies. First, you collect a lot of butterflies. Why would you do it? Well, once you have a lot of them, then you can find the patterns. And when you see the patterns, you can form things into groups. So once you have the groups, you can start to think of, is there an order in the system? Is it an order of evolution? Do things grow from one thing into another? We're doing this with planets now because of the large number of planets, but we're also doing it with something as boring as the positions of stars. There's now a satellite that has generated the positions of billions of stars in the universe. And by looking at where they are and how they move, we suddenly start movements. And we find that in our galaxy there are apparently older mergers of other small galaxies that have passed through our galaxies and affected the motions of stars, something which we would never have seen if we wouldn't have had access to this big data set. And this we're going to see in a lot of fields, that big data is ahead. And astronomy is ahead in this field. We have a lot of big data producers.
Oh, it's can we travel through wormholes? I like that question, but it moved away. Do you think the human race will escape the solar system and then our galaxy?
No.
No. Easy question.
Do you want to elaborate?
No, I think we've gone over that one, have we?
It will be a wormhole back to the same question again.
But Eric's point earlier of, well, the future human race, maybe cyborgs,
Yeah. Okay, if we could magically dump a obscene amount of funding on one space research topic, what would it be? You get to pick each one. Huh?
Who wants to start? Should I start?
Yes,
Okay.
start, because otherwise they will take that one.
Yeah, okay, all right. Think about your answers.
Rainbows.
Well, it can involve rainbows. So if we wanted, at the moment, all we can do, like if we walk outside right now and look up at the stars with our eyes, the stars are just tiny points of light. Even with the biggest telescopes we've built on the ground, almost all the stars in the sky are just points of light. We can't see any detail on them. There's a fancy thing you can do where you get a lot of telescopes to talk to each other, and it's sort of like telescope teamwork. And we've done this from the ground, but if we did this in space and got some satellites that were flying together like in sort of maybe a cross pattern. Like there was one here, one here, one here, and one here, and they were flying together and looking at a star that we knew had a planet. This would be one of the best ways for us to like zoom in and really see detail on those planets or those stars. And that's because building a really, really big telescope, like a telescope the size of a football field or something, you can't build a mirror that big. But by getting these telescopes to work together, they can sort of pretend to be a bigger telescope. And then we could maybe see interesting things on these stars. And if you get a big enough network of telescopes doing teamwork, then I don't know, maybe you can see continents or on these other planets, or maybe see their own biotopia that's having a conversation similar to this.
How many biotopia can you handle? That's the question. So what do you want to spend your money on?
Well, we have gone to the edge of the solar system, but we have never really investigated the planets beyond Jupiter. Well, there have been missions a long time ago, but it's time for a new one. So Neptune, I think, would be interesting. There are proposals all the time for new missions, but they cost an obscene amount of money. So,
will it be possible to get something down there?
Well, yeah, we've landed on other planets. We've landed on comets. It's just a question of where do you want to direct your resources. Is it worth the money and time to try to develop a lander that can go further down? Or so yes is the answer, but you can also get a lot of measurements from orbiting planets and moons and so on. So.
Mm-hmm. Yeah, I think I'm mainly working on theory, so as a theoretician, I would probably say like more efficient computers and just faster computers and maybe it's an easy answer, I guess. Not that much to develop in the answer.
But that's a good answer.
I think that an obscene amount of money must also be on something that should be extremely relevant for us as humans. And one thing that we know that happens regularly, except regularly is not very often, but it does happen, that is that the Earth can be hit by large objects. Large objects hitting the Earth is not a good thing for
Ask
life.
the dinosaurs.
The dinosaurs know it, but also before that there have been other cases where there have been huge effects on the Earth, which have and sometimes been good for us because we wouldn't exist if the dinosaurs hadn't
No, that's
disappeared.
true.
But I think we should spend then money on a kind of project to find a solution to what would we do if we do locate objects that eventually have a risk of impacting on the Earth. The risk of impacting on the Earth in a time scale of 100,000 years is realistic. If you go to 100 million years, it's almost certain that it's going to happen. So it's not something that's going to happen tomorrow, but I think it's something we have to start thinking about now, or how we can handle this, because the earlier you can do something about it, the better the result will be. Because if you find an object and you can only give it a slight change at this moment, then the effect to that object over 100,000 years will be huge. The only thing you have to make sure is that we don't accidentally then push it into the direction that
Not the
we
wrong
mess
way.
it up. No, that's true.
We had that question with the kids today, and we said we can probably be able to move those things away.
We don't have to be afraid at the moment. There's nothing that is coming up in the short term, but we know that in the long term this is going to
But
be a
if it
problem.
would come, could we do something right now?
Yes, if we want to, we could. But it's going to need an obscene amount of money.
Yeah, Bruce Willis, his fees are really expensive to hire him to get into a
Useless.
rocket. Yeah.
Oh, we are out of time. I'm so sorry. We just keep talking and talking. Thank you so much for enlightening us with all this new stuff. Space. It's cool. You must be very happy to work with space.
It's a very interesting job.
Yeah.
Yes, and thank you all for watching, both you in the room and on the internet. Thank you. Are we done in this?
Our friendly neighborhood narrator would just like to add that any unanswered questions shall be answered in the comments of this live stream. So in case anybody wants to find out the answers, we will get some astronomers to answer these questions. So no need to worry.
Or if you have any more questions now, please, when you have them standing here, what will happen in the future? Well, otherwise we will just say thank you. And for everyone who wants the telescope in the Observatorieparken, why my English is disappeared, is open for looking at stars, I guess. Or what are you looking at with that one?
Depends on
whether
weather is clear, but there will be astronomers there, so you can go. If you go to the backside of the observatory, you can get in, you can see the telescope, and if the weather is cooperating, they will show some things on the sky. And if you look, it could be a stellar cluster, or it could be a galaxy. Maybe later tonight it could be a planet, it could be Jupiter. So there could be a nebula, an old remnant of a supernova. That's the kind of things that they typically show.
The only thing we want to see is a black hole.
If tonight doesn't work, you could come back any Tuesday during the winter time. There will be telescope shows at 7 o'clock where you can come to the observatory and see the skies and see a nice object.
It's so cool. Thank you.
Let us end with an applause for our wonderful astronomers.
Yes.